In this video, we're going to talk about compound events, specifically one of those compound events. Remember that a compound event is one in which there are more than one possible outcomes. There are two types, independent and dependent, and in today's video, we're going to deal with independent compound events. An independent event is a type of compound event where the outcome of the first event, and this is the really big part, does not affect or change the outcome of the second event. We're going to show what that looks like in just a second when we start some examples. The operations for compound events is multiplication. So think of it this way. Multiple events needs multiplication. Just a nice way to remember that. Okay, so here's what an independent compound probability looks like. The question is asking what's the probability of spinning a red and rolling a 5. So here's what I mean by the events do not affect each other. When I look at this spinner, if I spin a red, that's not going to change any of the outcomes that are on this number cube over here. If I spin a yellow, it's not going to change the number 5 over here on this number die. It's still the exact same number die. So what happens is when you have two simple events that are kind of smushed together, that creates an independent compound probability event. So we treat it like we would the simple events. So if I look right here, I want red on the spinner. So that means I set up my probability and I look, there are 1, 2, 3 reds. So I have 3 over 1, 2, 3, 4, 5, 6, 7, 8 possible sections. So remember, that's setting up that simple probability. And then rolling a 5. There is only 1 5 out of a possibility of 6 outcomes on that die. So remember, just like I said in the past slide, multiple events requires multiplication. That is the only operation you will do with compound probability. You will never add, you will never subtract, you will never divide. So adding, subtracting, and dividing are big nevers when we're dealing with probability. So again, just like we've been practicing with our fractions, we've been dealing with this for a little while. We're going to simplify. We have this, you could cross simplify or up and down simplify as long as it's a numerator and a denominator. So 3 and 6 have 3 in common. 3 goes into 3 once. It goes into 6 twice. 1 times 1 is 1. And 8 times 2 is 16. So the probability of spinning a red and rolling a 5 is 1 1/16. This is the big key word, knowing that it's compound probability. They want to know the probability of both events happening at together. Another type of problem that you will see is a word problem. You need to pay very, very careful attention to the words in this word problem. So it says the picture above represents the dresser drawer of socks. What's the probability that you will choose a red sock, replace it, and then choose a black sock? The big, big, big important phrase that you need to note is replace. With independent probability, any synonyms of this phrase to replace go with independent. So to put back, not take out, to return. Any of these words are your independent probability phrases. That lets you know that you're putting the sock back so that the total in the drawer remains the same. So when we look right here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total socks in that drawer. So what happens is when you put the first sock back after you've looked at it and you put it back, the second time you draw out a sock, there are still 12 socks. So they want to know the probability of getting a red sock. There are 2 red socks out of a total of 12. And they also want to know the probability of a black sock. There are 3 black socks out of 12 because you put that first sock back. Again, multiplication is the operation that goes between multiple events. In this specific problem, you can simplify up and down or diagonally. It really doesn't matter. Up and down, I'm going to just do it that way since it's easier. This becomes 1/6 because the common factor is 2. This becomes 1/4 because the common factor is 3. So you would just divide by 3 here, divide by 2 here, divide by 2 here to get the two different ones. So I'm going to actually rewrite this so that you could see what I have. I have 1/6 times 1/4. Top times top is 1. Bottom times bottom is 24. So the probability of getting a red sock, putting that red sock back in the drawer, and then getting a black sock is 1 out of 24.